Alright, I'm Jake Torgerson. For this presentation I'm doing the Ulam spiral, and we talked about some other spirals in this class, but the Ulam spiral is quite a bit different. So pretty much this guy, Stanislaw Ulam, created this, he was writing on paper and he created this grid, and it's also called the prime spiral because he ended up highlighting all the numbers, but I'll come back to this slide in a bit. So how was it developed? In 1963, Stanislaw Ulam, he was pretty much in a meeting that he was bored in, I guess, and he was just started doodling on paper, and he wrote every number starting in the middle. So he started with 1 in the middle, and then he went to 2, 3, 4, and he went counterclockwise and just kept going. So then he ended up circling every prime number as he went along, starting with 2, obviously. And then he noticed that as he went along, some of the primes ended up making weird diagonal type of things. So then I guess later on I'll talk about how it's been developed with computers that you can just make it, so it's nearly infinite type of thing. But so Ulam was a Polish-born mathematician, and he escaped Poland right before the World War II with his brother, but the rest of his family was killed in the Holocaust, unfortunately. He ended up working on the Manhattan Project, which is kind of a coincidence in my opinion, because he escaped Poland from the World War, and then he ended up helping the Americans win eventually. He's also famous for work on spacecraft systems. And then there's a quote in the Pickover book that just says something about his findings and his later works. It says, "Ulam's doodlings in the twilight zone of mathematics are not to be taken lightly. It was he who made the suggestion that led him and Edward Teller to think of the idea that made possible the first thermonuclear bomb." So some people didn't really think a lot of this finding. It wasn't necessarily the Ulam spiral that led to the work of the Manhattan Project, but more just his thinking in general. And there's a website here at the bottom that's a link on more of his work with the atomic bomb. So some of the patterns, the main one I talked about was the diagonals and the primes. So obviously all the numbers are odd other than 2 for the primes, and there's another quote that says, "A random selection of odd numbers does not result in linking of diagonal lines to this extent." So they're saying if you pick out any random odd number, whether it's prime or not, you're unlikely to get a definite diagonal pattern, versus if you pick an odd number that's prime, you'll probably most likely get some sort of diagonal pattern. And then there's another website there that it's just entirely on the Ulam spiral, and it does a bunch of different cool things on there. And then this pattern, it's kind of, obviously it's computer made, but you can see like some of these would be prime number sequences, that some of those diagonals in there. So how's it used in math and how is it impacted? Ulam's simple demonstration highlights the use of the computer as a kind of microscope that allows mathematicians to visualize structures that may lead to new theorems. So when he discovered that, it wasn't necessarily the computer that he did it on, obviously right away, because he did it on paper, but I think it kind of relates to Jacob Lear's presentation on how it helped discover more, more development with computers and mathematics together, kind of. So, and then just like that bullet point says, the discovery provided growth and impact to the increase in experimental mathematics toward the end of the 1900s. And then the last quote from the Pickover book says that Ulam's spiral grids have added a touch of fantasy to speculation about the enigmatic blend of odor and haphazardly in the distribution of primes. So I think that just kind of has to do with the fact that it was kind of a weird discovery, and it just kind of led to more thinking versus a specific topic in math. Those are my sources and photo sources.